So today's lesson is going to be on experimental versus theoretical probability. So those are two types of probability that you will learn in 7th grade. Make sure you've done these two questions and gotten them checked before you move on. So please raise your hand when you are done with the two recall questions, because these are not related to theoretical or experimental probability. They are ones that we have covered in our previous classes. So pause the video now. Okay, now that you've gotten those checked, we're going to go ahead and give you the definition of theoretical probability. So theoretical probability is the probability of what should happen. So that'll be your first blank, probability of what should happen. In other words, it's the probability that we expect to happen, or what is expected, or in theory, right? We see theoretical, in theory, this should happen, but it doesn't always happen. We will continue to use this formula for theoretical probability. So again, the probability of an event happening would be found from the number of favorable outcomes over the number of possible outcomes. So let's go through some examples first. A says Santi flips a coin 10 times. On his 11th flip, what is the probability of it landing on a tail? Okay, well, if we think this through, how many favorable outcomes are there on a coin? How many favorable outcomes, meaning how many tails? Okay, well, there's one tail over how many outcomes on a coin? We know there are two outcomes, a head or a tail. So it doesn't matter what happened in his flip 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Doesn't matter what happened then. On his 11th flip, he has a 50-50 shot, or a 1 out of 2 chance of landing on a tail. So you might notice, like, this is just like the probability we were doing last class. Theoretical is just, it's just like the normal probability. So B says if you randomly choose one of the letters shown, what is the theoretical probability of not choosing a X or a R? So not choosing an X or R. So I'm going to cross out the X and I'm going to cross out the R. And that's how many would be left, right? So 1, 2, 3, 4, 5. Letters that are not X or R, there are 5 out of, now I would count up the total number of letters. So 1, 2, 3, 4, 5, 6, 7 total letters. Okay, again, this probability is just like the probability we've been doing. Now, when we talk about experimental probability, that is the probability of what actually happened. And if we think about it, it makes sense. It's an experiment, right? So we are going to use this formula for experimental probability. So the probability of an event happening is found by the number of times an event occurred over the total number of trials. Okay, so the number of times the event that they're asking for in the question occurred over the total number of trials, the total number of times you did something. Maybe if you flipped a coin 50 times, that would go on the bottom. If you rolled a dice 100 times, that would go on the bottom. So we'll go over some of the examples below. Let's see, you roll a dice 100 times, okay, and your data is here. So 100 rolls, landing on a 1, 2, 3, 4, 5, or 6. That's what this means. And then frequency is just the amount of times we landed on a 1, or landed on a 2, landed on a 3, or so forth. So A says, what is the probability, or the experimental probability of rolling a 5? So the moment it says the words experimental probability, I'm going to look at my table, okay? I'm going to actually use the data if it says experimental probability, and I'm looking for the experimental probability of rolling a 5. Well, how many times did I roll a 5? 18, right? Out of the total number of trials, so out of 100 trials. Now remember, we always want to make sure we reduce. So these are both even, I can divide by 2. So 18 divided by 2 would give me 9, and 100 divided by 2 would give me 50. So 9 over 50, 9 can only be reduced by 3 and 50 cannot. So that's our experimental probability of rolling a 5. Now the next one says, what is the experimental probability of rolling an odd number? So again, it asks for experimental probability, so we will use the data. If it didn't say experimental probability and it gave us data, we would not use it. You have to be very careful when you read. So let's look at our odd numbers, 1, 3, and 5. Well, we landed on an odd number 16 plus 22 plus 18 times. So we need to add those up. 16 plus 22 plus 18. And see what that gets you. Okay, so it should get us 56. So we'd say we landed on an odd number 56 times out of 100 trials. Now these are both even. I could divide by 2 to simplify, but I can also divide by 4, and I'm going to do that since it will get me there in one time of dividing. So 56 divided by 4 will give me 14, and 100 divided by 4 is going to give me 25. So that was my experimental probability of rolling an odd number. Okay, and then the last one says, what is the experimental probability of rolling a number less than 3? So numbers less than 3 would just be 1 and 2. So we're going to add up 16 and 20. So 16 plus 20. And that would give me 36. So the experimental probability of rolling a number less than 3 would be 36 out of the total number of trials out of 100. So then I'm going to divide both by 4. And I'm going to get 9 out of 25. Okay. All right, now at the bottom, we're going to compare the experimental probability with the theoretical probability. So we're still dealing with the same table and the dice. We roll the dice 100 times, the results are here. But this problem says, it should say D, sorry. This one says, what is the probability of rolling a 5? There's nowhere in this that says based off of the table or what is the experimental probability. So because of that, we do not use the table. If it doesn't ask for experimental probability or based on the data, we do not use the table. It's just thinking theoretical. So what is the probability of rolling a 5? Well, we're going to go back to our normal probability thinking how many 5s are there on a dice? Only 1. So we'd say 1 out of 6 outcomes. So that's the difference between theoretical probability and experimental probability. E says, what is the probability of rolling an odd number? Well, same thing. I'm not going to use my data because it doesn't say experimental probability or based on the data. So there are 3 odd numbers out of 6 outcomes. I can divide that by 3 and we know that that's 1/2. So if you look just above E, problem B was the experimental probability of rolling an odd number, and that was 14 out of 25. So the experimental probability of rolling an odd number, let's divide that, 14 divided by 25, and that's 0.56. And the theoretical probability we know is 0.50. So in this case, the experimental probability was actually a little higher than the theoretical probability. So it landed on an odd number more times than we expected it to. Okay? All right, why don't you go ahead and flip over your paper, and you will see that you are going to do an experiment. So you are going to roll a dice 20 times, and you're going to record what you got. So for instance, on the first one, say I roll my dice, which you will receive a dice. I roll my dice and I get a 2, so I'm going to put a tally mark for 2. Then I roll my dice again and I get a 4, so I'm going to put a tally mark for a 4. Then I roll my dice again and I get a 6. I'm going to put a 6. Then I roll my dice again and I get another 6. You're going to keep doing this until you have 20 total. Okay? So you'll put the total number here. So say I had 2, 7, 3, that's 10, like that, okay? You would put the total on the end, and then you're going to answer the question. So obviously yours should not look like this because you're going to do the experiment yourself. You'll do the experiment, you'll answer the questions based off of your data, and then finish up with the you try questions. Okay? All right, good luck.